Welcome to the DIY Honda Garage channel. The DTC P0341, associated with the Honda Odyssey models from 2011 to 2017, indicates a problem related to the camshaft position, CMP, and crankshaft position, CKP sensors. These sensors work in synchrony to provide accurate timing data for the engine's operation. Specifically, the CMP sensor tracks the position of the camshaft, while the CKP sensor monitors the crankshaft's position. Any discrepancy in their readings can cause a misalignment in the engine's timing, leading to performance issues. According to the diagnostic troubleshooting information, this issue is classified under incorrect phase detected, suggesting a potential fault in the timing mechanisms or sensor connections. Prior to beginning the troubleshooting process, it is essential to document the freeze frame data and onboard snapshots for later analysis, which will aid in understanding the conditions of failure. In the context of DTC P0341, both the camshaft position CMP sensor and the crankshaft position CKP sensor are critical components in ensuring the engine's timing is synchronized. The CMP sensor, usually located near the camshaft assembly, is responsible for detecting the position of the camshaft, which is vital for optimizing fuel injection and ignition timing. In contrast, the CKP sensor is strategically placed near the crankshaft, allowing it to monitor the rotational position and speed of the crankshaft. Together, these sensors convey real-time information to the powertrain control module, PCM, enabling it to adjust engine performance efficiently. When either sensor indicates incorrect timing, it can severely disrupt engine performance and efficiency. Proper placement and functionality of these components are crucial to avoid triggering diagnostic trouble codes such as P0341. There are several possible causes for the DTC P0341, each of which must be considered during the troubleshooting process. First, poor connections or loose terminals at the CMP sensor, CKP sensor, or the PCM could lead to inaccurate phase detection. This is a relatively common issue, often resulting from wear and tear or improper installation. Second, the timing belt plays a pivotal role in ensuring both sensors operate in synchrony. If the timing belt is damaged or frayed, it can alter the timing readings, thus triggering the DTC. Lastly, a malfunctioning powertrain control module, PCM, may incorrectly interpret the signals from the CMP and CKP sensors, leading to the phase detection issue. Diagnosing these factors systematically is essential to resolving the error and restoring proper engine function. The symptoms associated with DTC P0341 can vary, but typically manifest as noticeable issues in engine performance. Drivers may experience stalling or misfiring, particularly during acceleration or under load. This is due to the engine's inability to accurately time fuel injection and ignition timing, which can lead to a rough operating condition. Additionally, the check engine light will illuminate, indicating a fault that requires attention. Other symptoms may include a decrease in fuel efficiency and overall driving performance, making it crucial to address the underlying issues promptly. Recognizing these symptoms can help the owner seek repairs in a timely manner, potentially preventing further damage. The first troubleshooting step for DTC P0341 involves preparing the vehicle for diagnostic testing. Begin by turning the ignition switch to the on/to position without starting the engine. This action powers the vehicle's electrical systems, allowing the Honda Diagnostic System, HDS, to communicate with the vehicle's onboard computer. After the ignition is prepared, utilize the HDS to clear any existing diagnostic trouble codes, including P0341. Following this, start the engine and allow it to idle, which is a crucial step. Idling enables the sensors to operate under normal conditions, making it possible to monitor for any new diagnostic trouble codes that may appear. This preliminary step is fundamental in isolating whether the issue persists or is an intermittent problem. In the second troubleshooting step, use the HDS to check for any pending or confirmed diagnostic trouble codes, DTCs. After starting the engine and allowing it to idle, the system will indicate whether DTC P0341 is currently present. If the code appears, this confirms that the issue is ongoing and needs to be addressed in subsequent steps. However, if the DTC is not present, this suggests that the PCM may not detect the error presently, potentially indicating an intermittent failure. If this is the case, check for poor connections or loose terminals at the sensors and the PCM to ensure they are secure. Recognizing whether the DTC is pending or confirmed is essential for determining the subsequent troubleshooting actions. The third troubleshooting step revolves around evaluating the camshaft timing. Using tools and visual inspections, check to ensure that the camshaft is properly aligned according to factory specifications. Proper camshaft timing is crucial for optimal engine performance, as it directly influences the synchronization of valve movement and ignition timing. If the timing is found to be out of spec, it will need to be reset. A misaligned camshaft could be the root cause of the DTC P0341 being triggered. Conversely, if the timing is confirmed as correct, the troubleshooting process continues. Additionally, verifying the timing reinforces the diagnostic pathway to ensure that the issue does not lie within the timing system itself, allowing for a more focused approach in subsequent steps. In the fourth step of troubleshooting DTC P0341, you will check the condition of the timing belt. The timing belt is a vital component that synchronizes the rotation of the camshaft and crankshaft, essential for the engine to function correctly. Inspect the belt for any signs of damage, fraying, or wear that could affect its performance. If the timing belt is compromised, it will need to be replaced along with the timing belt auto tensioner. This replacement is essential to ensure proper synchronization of the engine's components and to prevent potential engine damage. If the belt appears intact, you will proceed to the next steps in the troubleshooting process. Addressing any issues with the timing belt is critical to resolving the underlying issue indicated by DTC P0341. Step 5 involves resetting the PCM, which is the powertrain control module, after confirming the integrity of the timing components. Begin by turning the ignition switch back to the on second position. Once in this mode, utilize the HDS to reset the PCM. This action allows the PCM to clear its adaptive learn values and reset its baseline for idle conditions. It is essential to conduct this step after any repairs or replacements to ensure that the PCM can accurately relearn the engine's operating parameters. After resetting, proceed to complete the idling learn procedure, followed by the CKP pattern clear and CKP pattern learn procedure, which are necessary for the PCM to learn the new patterns of the crankshaft position sensor. Effectively resetting the PCM is key to resolving DTC P0341. In this sixth step, the focus is on executing the CKP pattern learn procedure. This procedure is crucial as it allows the powertrain control module, PCM, to recognize and adapt to the specific patterns of the crankshaft position, CKP sensor. Starting the engine and allowing it to idle helps establish a baseline for engine operation where the PCM can learn the effective timing. This adjustment is particularly vital after resetting the PCM and replacing any faulty components. Monitoring the engine during this period provides feedback to the PCM, essential for fine-tuning engine performance. Proper execution of this step helps ensure that the engine runs more smoothly while minimizing the chance of re-encountering DTC P0341. The seventh step is to re-evaluate the situation by checking for any pending or confirmed DTCs, once again using the HDS. This serves as a diagnostic checkpoint following the PCM reset and CKP pattern learned. If DTC P0341 is present again, repeat the investigation into poor connections or loose terminals at the CMP sensor, CKP sensor, and the PCM, reinstating the troubleshooting process from step 1. If the DTC is not indicated, it suggests that the earlier troubleshooting fixed the root cause and that the system is functioning correctly. This step is crucial, as it verifies whether the corrective measures have been effective or if further investigations and repairs are necessary. In the eighth and final troubleshooting step, you will need to monitor the OBD status for DTC P0341 in the DTCs menu using the HDS. This step shows whether the vehicle's onboard diagnostics have successfully cleared the fault code. If the HDS indicates passed, it confirms that the troubleshooting is complete and the vehicle's systems are functioning properly. However, if the indication is failed, it suggests persistent issues, and you should inspect for poor connections or loose terminals at the CMP sensor, CKP sensor, and the PCM again. If the HDS shows not completed, the steps before this one must be diligently followed to ensure the system performs as expected. Accurate monitoring during this step is essential for determining the resolution of the DTC P0341. In the final repair verification step, the primary goal is to ensure that there are no pending or confirmed DTCs left in the system after all troubleshooting steps have been executed. This involves using the HDS to double-check that the engine control systems are functioning properly. Additionally, confirming full system functionality is critical, not only for engine performance, but also for overall vehicle operation. It is vital to validate that all errors associated with DTC P0341 are fully resolved, preventing future complications. Thoroughly inspecting the sensors, connectors, and electrical systems will help guarantee the integrity of the entire setup. When verification is achieved, the driver can be reassured that any issues related to the camshaft and crankshaft position sensing have been effectively addressed. Preventive maintenance is crucial to avoid future occurrences of DTC P0341. Regular inspections of the timing belt should be conducted to ensure it remains in good condition, as a damaged or frayed belt can lead to serious engine timing issues. Additionally, checking the connections and terminals of the CMP and CKP sensors periodically can prevent intermittent failures due to corrosion or loose fittings. Maintaining clean, secure electrical connections is critical for the reliable operation of the engine management system. Implementing these preventive measures not only helps maintain optimal vehicle performance, but also reduces the likelihood of costly repairs. A proactive approach towards maintenance can significantly enhance the longevity and reliability of the vehicle's engine components. In conclusion, understanding and addressing DTC P0341 in Honda Odyssey vehicles is critical for maintaining optimal engine performance. The camshaft and crankshaft position sensors are fundamental for accurate timing and efficiency. If errors arise in their functionality, it is crucial to follow a systematic troubleshooting approach, as outlined. Addressing issues promptly helps prevent more severe complications down the line. ensuring the integrity of engine components. Additionally, regular inspection and maintenance will substantially reduce the occurrence of similar diagnostics in the future. Elevating awareness of these factors underscores the importance of regular vehicle care and timely intervention in troubleshooting processes. Please like and subscribe to the channel. See you next time.